students, welcome to our YouTube channel Experience Tutor. Today we'll discuss Class 12 Physics Get More Than 95% Marks series, Electromagnetic Induction, Chapter 6, NCERT Line by Line, Part 6. Before we begin today's class, we have a humble request. If you have not subscribed our channel, please subscribe it. Please like our videos and share it at as many shares as possible. Please click on the bell icon so that you won't miss any of our important videos, because you will get an automatic notification whenever a new video is uploaded by us. So let us begin today's class. In the last class we have done till mutual inductance. Today we'll start with self-inductance. In the previous subsection, we considered the flux in one solenoid due to the current in the other. It is also possible that EMF is induced in a single isolated coil due to change in magnetic flux through the coil by means of varying the current through the same coil. This phenomena is called self-inductance. Self-induction. In this case, flux linkage through a coil of n turn is proportional to the current through the coil and expressed as n phi b is directly proportional to I. So n phi b is equal to Li, where constant of proportionality L is called self-inductance of the coil. It is also called coefficient of self-inductance of the coil. When the current varied, the flux linkage with the coil also changes and an EMF is induced in the coil. Using equation 6.15, the induced EMF is given by E is equal to minus d n phi b upon dt. E is equal to minus L di by dt. So what happens here? Instead of phi, we have put this value. N phi b. Instead of I, we have put this value n phi b by dt. So, and instead of n phi b, we have written Li. So, minus Li by dt. So, this is the ultimate equation. So, actually, we have started with the statement that flux linkage through a coil of n turn is proportional to the current through the coil. So we have written this sentence, we have represented it in mathematically. So when proportionality gets removed, we put a constant that is called proportionality constant. Here L is the proportionality constant. So, and L is known as self-inductance of the coil or coefficient of self-inductance of the coil. So now E is equal to, we can write di by dt minus di by dt, induced EMF E is equal to minus di by dt. And instead of I, we have written n phi b by dt, and instead of n phi b, we have written Li. So L is constant, di by dt. Thus, self-induced EMF always opposes any change, increase or decrease in the current of the coil. So it opposes, the negative sign indicates that it opposes any change in current, either increase or decrease. It is possible to calculate the self-inductance of the circuit with simple geometries. Let us calculate the self-inductance of the long solenoid of cross-sectional area A and length L, having n turns per unit length. The magnetic field due to the current I flowing in the solenoid is B is equal to mu naught Ni. Neglecting edge effect as before, the total flux linkage in the solenoid is equal to N phi B. So N is equal to, we can write NL. Phi B we can write uh, mu naught Ni A. A is the area of cross section. So mu naught N square A L I. NL is the total number of turns. Thus, the self-inductance L is equal to N phi B upon I. Why? Because we have already seen N phi B is equal to L I. So, L is equal to N phi B upon I. Here we have written the same. N phi B, instead of N phi B, we can write mu N square, this whole value. So if we write L is equal to N phi B mu naught N square A L I upon I get cancelled, then L will be equal to mu naught L N square A L, and this is the value which we get in equation 6.17. If we fill the inside of the solenoid with a material relative permeability is equal to mu r, for example soft iron, which has a very high relative permeability, then L is equal to mu r mu naught L square N square Al, that is 6.18. The self-inductance of the coil depends on its geometry and on the permeability of the medium. The self-inductance EMF is also called back EMF. It is also called back EMF as it opposes any change in the current in the circuit. Physically, the self-inductance plays the role of inertia. It is the electromagnetic analogues of mass in mechanics. So work needs to done against the back EMF E in establishing the current. The work done in storage as magnetic potential energy. For the current I at an instant in a circuit, the rate of work done is d omega t dw upon dt is equal to modulus of E I. So how come this dw by dt is equal to? Because for the work done is stored as magnetic potential energy. For the current I at an instant in the circuit, the rate of work done. The rate of work done is power. So we can write power is equal to V into I. Correct? Then power is rate of work done. We can write it. And V is equal to the EMF, magnitude of EMF or the value of EMF into I. So now dW by dt is equal to Li di by dt. From where we got this value? Just we have put the value. Just we have put the value of E. That's it. So, and we got Li di by dt. Now, so till here you are with me? Now, total amount of work done. If we want to find out the total amount of work done, then we'll integrate it. Integration of dW and integration of 0 to I Li di. Now integration of dW will give W and integration of Li di 0 to I will give I square by 2. So integration of dW and integration of 0 to I Li di. So this will give W, this will give Li, and I di will give I square by 2. So Li I square by 2, which is this equation. This expression reminds us of mv square by 2 for the mechanical kinetic energy of the particle of mass m, and shows that L is analogous of m mass and L in the electric inertia. L is electrical inertia and opposes the growth and decay of current in the circuit. Consider the general case of current flowing simultaneously in two nearby coils. The flux linked with one coil will be the sum of two flux exist which exist independently. Equation 6.9 would be modified into Ni phi N1 phi 1 M11 I1 plus M12 I2, where M11 represents the inductance due to the same coil. If you remember in the previous video, we have written M12 and M21 because inductance because there were two coils and inductance of one coil with respect to another. So we have written M12. But here there is only one coil, so we have written M11. Now, therefore, Faraday's law E1 is equal to minus M11 di by dt minus M12 di2 by dt. So, in the presence of second coil, the inductance of the first coil with respect to second coil, this whole value, and for the self inductance, this value. So M11 is the self inductance and is written as M11 is written as L1. So L1 minus L1 di1 by dt M12 di2 by dt. This is the expression for the induced EMF in this case. Now let us see an example. 6.10 A. Obtain the expression for the magnetic energy stored in a solenoid in terms of magnetic field B, area A, length L of the solenoid. How does the magnetic energy compare with the electrostatic energy stored in the capacitor. From equation 6.19, magnetic energy UB half Li square is equal to half L B upon mu naught N square. Since B is equal to mu naught Ni for the solenoid, we have done it this relationship in previously. So just put the value of B as mu naught Ni and B square mu naught square N square I square, and you just solve it, and after solving you get this. Now we have to understand the calculation from here to here, how we got it. So from equation 6.19, the magnetic energy is UB is equal to half Li square. How come we got this? Let us check 6.19. You see this one, half Li square. This is the energy. Fine. So no issues in this. Second, B we have put mu naught Ni. So UB is equal to half Li square. It is given in, it is given equation 6.19. Fine. Now we know uh, B is equal to mu naught Ni. Mu naught Ni. Now put the value. So instead of I, we can write B upon mu naught N. So now put the value of I here. So half, which will be equal to half L B mu naught N I square. So this is square. Now instead of L we can write L is equal to mu naught N square AL, where in equation just now we have done this equation few minutes back, 6.17. So instead of L, just put this value. So we'll get half mu naught N square AL multiply by B square mu naught square N square. So you cancel one mu naught square, N square also got cancelled. So what left? What left? Half mu naught left. One of the mu naught is left here. Nothing is left in the denominator. In the numerator, B square AL is left. So 1 by 2 mu naught B square AL is the final derivation for the energy UB. Now in B, the magnetic energy per unit volume is UB upon V. Instead of V volume, we can write area, cross-sectional area into length. So AI, AL, Now put the values of UB what we got here. So let us UB per unit volume per unit volume UB upon V. So put the value of UB as half mu naught square V square AL upon V, we can write AL. So AL here length. So AL, if we get AL get cancelled. So energy per unit volume UB small ub will be equal to half mu naught upon 2 mu naught V square upon 2. We have already obtained the relation. So here we got the same thing, same value. So we have already obtained the relation from the electrostatic energy stored per unit volume in a parallel plate capacitor. So UE is equal to half epsilon naught E square. So in both the cases energy, so it looks similar to this equation. In both the cases energy is proportional to the square of the field strength. Here it is magnetic field strength V square, and here it is electric field strength E square. E. Equations 6.20 and 2.77 have been derived for a special case, a solenoid and a parallel plate capacitor, respectively, but they are general and valid for any region of space in which magnetic field or the electric field exist. So we have done it. Now we'll do start 6.10 AC generator. The phenomena of electromagnetic induction has been technologically exploited in many ways. The exceptionally An exceptionally important application is the generation of alternating currents AC. The modern AC generator with a typical output capacity of 100 megawatt is highly evolved machine. In this section, we shall describe the basic principle behind this machine. The Yugoslav inventor Nikola Tesla is credited with the development of the machine. As was pointed out in section 6.3, one method to induce an EMF or current in a loop through a change in loop's orientation or change in effective area. As the coil rotates in a magnetic field B, the effective area of the loop, the face perpendicular to the field, is A cos theta, where theta is the angle between A and B. This method of producing a flux change in the principle of operation of the simple AC generator. An AC generator converts mechanical energy to electrical energy. So what is the main principle here for AC generator? You see, let us go through the main principle. One method of induce One method to induce an EMF or current in a loop is through a change in the loop's orientation or change in effective area. So change in how can one of the method of inducing EMF is or is or induce EMF or current in a loop is through the changing of loop orientation or by changing the effective area. Fine. On this is the basic principle for AC generator. Now, as the coil rotates in the magnetic field B, the effective area of the loop is A cos theta, where theta is the angle between A and B. A is the area and B is the magnetic field. So there are this is the north pole, this is the south pole of the magnet, here is the rectangular coil, and here slip rings, here alternating EMF, and here are carbon brushes. Now AC, so this is the basic principle. So at any point in time, the angle between A and B is theta. So at any point of time, the area of the loop is A cos theta. This method of producing flux, producing a flux change is the principal orientation of simple generator. An AC generator converts mechanical energy to electrical energy. The basic elements of an electric AC generator are shown in figure 6.16. It consists of a coil mounted on the rotor stuff, rotor shaft. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. The coil, called armature, is mechanically rotated in uniform magnetic field by some external means. The rotation of the coil causes the magnetic flux through it to change. So an EMF is induced in the coil. The ends of the coil is connected to external circuit by means of slip rings and brushes. So remember, this is a 5-mark question which is most important question of this chapter, AC generator. So this part gives the principle or working of the generator. This part gives the construction or details, construction plus working. So to get full marks here, you have to write the principle, you have to write the working, or don't write construction, you write working or construction plus working as you wish. So this is extended, working is extended uh, till the whole mathematical, or you can separate the construction in construction you have to draw the diagram, so keep it working, don't write this, just write construction till here, construction, draw the figure, then write the constructions. So here construction. Now after that working this whole is working. So these are the three parts. To get full marks, you have to mention all this part concisely, so that and you should not miss any of the details. So let us again see the construction part. So the basic elements of AC generator are shown in figure 6.16. So you will have to draw the figure. It consists of a coil mounted on a rotor shaft. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. The coil called armature. So this is the coil, rectangular coil. This is called armature. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. So axis of rotation, this is the axis of rotation. This is perpendicular to the direction of the magnetic field. The coil called armature, this coil is called as armature, is mechanically rotated in the uniform magnetic field by some external means. So it is rotated mechanically by some external means. By any way, we rotate this coil. The rotation of the coil causes the magnetic flux through it to change. So as soon as it starts rotating, the magnetic flux changes. So an EMF is induced in the coil. As soon as the magnetic flux is changing, the EMF will be induced in the coil. The ends of the coil is connected to the external circuit by means of slip rings and brushes. So the end of the coils, two wire of the coil, end of the coils are added to external circuit by uh, uh, carbon brushes and slip rings. The induced EMF or alternating EMF can be flow through this wire. When the coil rotates with a constant angular speed omega and angle theta between the magnetic field vector B and the area vector A of the coil at any instant t, theta is equal to omega t, assuming theta is equal to 0 degree at t is equal to 0 degree. So at any instant theta is equal to omega t. So you see, what is displacement? Displacement, say if we say displacement is t, then what we can write in terms of velocity and time? It is v into t. So for angular displacement, we write theta instead of d. So instead of linear velocity, we'll write here angular velocity, and t will be same as in linear and angular, no difference. So theta is equal to omega t. No, till here you are with me? Okay, thank you. Now, as a result, the effective area of the coil exposed in the magnetic field lines changes with time. And from equation 6.1, the flux at any time t is phi b is equal to ba cos theta, that is ba cos omega t. Instead of theta, we have written omega t. So from Faraday's law, the induced EMF for the rotating coil of n turn is then E is equal to minus n d phi b by dt, that is minus nba d cos omega t dt. Thus, the instantaneous value of the EMF is E is equal to nba omega sin omega t. How we got this? Differentiation of cos omega t is minus sin omega t, and differentiation of omega t is omega. So we came up NBA is already there, and cos omega t's differentiation is omega sine omega t minus omega sine omega t, and where NBA omega is the maximum value of the EMF which occurs when sine omega t is plus minus 1. If we denote NBA omega as E naught or E0, then we can write E is equal to E0 sine omega t. This is equation 6.22. Since the value of sine function varies between plus 1 to minus 1, so the sign or the polarity of EMF changes with time. Note from figure 6.17 that the EMF has its extreme value extreme value theta is equal to 90 or theta is equal to 270 degree, as change of flux is greatest at this point. The direction of the current changes periodically, and therefore the current is called alternating current. So periodically direction changes, so it is called alternating current. Omega is equal to 2 pi nu. So we can write E is equal to E naught sine 2 pi nu t. We have put the value of omega here, 2 pi nu, where nu is the frequency of the revolution of the generator coil. Note equation 6.22 and 6.23 gives the instantaneous value of EMF. E varies between plus E naught and minus E naught periodically. We shall learn how to determine the time average value for the alternating voltage and the current in this chapter. So stage 1, the plane of the armature is perpendicular to the magnetic field. Stage 2, when the armature rotates through 90 degree to the plane, and armature after 180 degree, armature rotates after 270 degree, and fifth stage is 360 degree. So from 90 degree, first is 90 degree, then plane of the armature is perpendicular to the magnetic field, so it rotates 90 degrees. So 90 degree, the cycle completes. Again the cycle completes at 360 degrees. So 90 degree, then 180, then 270, then 360. So it is a sine curve. In commercial generator, the mechanical energy required. Okay, anything more needs to be explained here? So direction of the magnetic field is given here. Anything else? Only this figure is showing that it is a sine curve, and induced EMF is marked when it is maximum. This is the time t by 4, t by 2, 3t by 4 in this way, and nothing else. I think everything has been explained. Okay. In commercial generator, the mechanical energy required for rotation of the armature is provided by water falling from a height, for example, from dams. These, these are called hydroelectric generators. Alternative, water is heated to produce steam using coal and other sources. The steam is at high pressure produce the rotation of the armature. This is called thermal generators. Instead of coal, if a nuclear fuel is used, then it is called nuclear power generators. Modern day generators produce electric power as high as 500 megawatt. One can light up 5 million 100-watt bulbs. In most generator, the coil are held stationary. It is electromagnets which are rotated. The frequency of rotation is 50 Hz in India. In certain countries such as USA, it is 60 Hz. This is all about AC generator. Now let us solve one of the example. Kamla pedals a stationary bicycle. The pedal of the bicycle are attached to a 100 turn coil of area zero point 0.1 meter square. The coil rotates at a half of revolution per second and it is placed in a uniform magnetic field 0.01 Tesla perpendicular to the axis of rotation of the coil. What is the minimum voltage generated in the coil? So F is equal to 0.5 Hz, N is equal to 100, A is equal to zero point 0.1 meter square, B is equal to zero point 0.01 Tesla. Now from equation 6.21, E naught is equal to NBA 2 pi nu. Just put the values. So maximum voltage got this. The urge we urge you to explore such alternative possibilities for our power generations. And this is the end of this chapter. So basically, let us review what we have done. Now we have started with we have started with today we have started with self inductance. So we have done the self induction concepts. We have also done self inductance. What is self inductance? We have done few one of the sum related to self inductance concept, and then we have learned about the principle, construction, and working of AC generator, and some conclusions for AC generator. What are the different types of generator like hydroelectric generator, thermal generator, nuclear power generators, etc. And we have solved few of the one of the examples, and this is the end of this chapter. Before we end our session, we request you again to please subscribe our channel and please like and share our videos, and please click on the bell icon to get automatic notification whenever a new video is uploaded. In this way, you will not miss any of our important videos. Thank you very much. Again, thanking you to watch this video, and again thanking you that you are for your support and watching our videos. Thank you.